below, and then it'll click up. Please feel free to use that to ask any questions, and with time permitting, we'll try to answer as many as we can. The Commission appreciates the time and the effort each of the speakers has put into their presentations, and we're sure that everyone attending today will learn some new tools and ideas to help them grow, harvest, and market their hardwoods from these experts. We will also be posting the symposium proceedings on our website in the near future. Our first speaker today is going to discuss silviculture assistance to growing hardwoods, and Brian Morris is from the Washington State Department of Natural Resources. He is a silviculturist for the DNR. He's managed their red alder reforestation program since 2014, and just here in October, he moved into his current role of manager of the DNR's Webster Forest Nursery. Brian will discuss alder site and seedling selection, and how that can determine success for planting efforts, resources for site identification, and seedling selection, and landowner assistance. So Brian, it's all yours. I'm going to mute myself if I can figure out how to do that.
Thank you. We'll try and get my screen shared here. You want that one?
There it goes. That looks good.
Sorry, I was reviewing things when I shared screen. It jumped to the slide a few slides in. So thanks, Joe. My name is Brian Morris. I'm currently the Webster Nursery Manager for Washington Department of Natural Resources. But since 2014, up until this past October 2014 until October of 2020, I was a silviculturist primarily focused in Southwest Washington. I did a lot of work with red alder across Western Washington, and everything from site selection, some harvest unit identification to seedling development with the nursery. So we're sharing just a little bit about kind of some lessons we've learned, some things we're working on, and some resources people can use for identifying sites where to plant alder and things to look out for they're both good and bad, I guess. So again, going into site selection, so red alder is it grows. You can find it all over all over Western Oregon and Washington. But in terms of regenerating it, it is kind of sensitive to site selection. The site that you pick is pretty important to have a successful planting. We're going to go through some pieces, and the image on the right is just a freshly planted seedling, and the image on the left is kind of more or less what we're looking for, in 10 years or so. So just a little background on red alder. It is a pioneer species, a shade intolerant pioneer species. And so its natural history is to come in immediately following disturbance, after fire, after landslide. We've all noticed, it comes in real quick after road construction. If you don't mow a hayfield for a few years, it might become an alder stand. So its natural process is to come in really quick. And to seed in really, really heavily, thousands of trees per acre initially. And then over time, those thousands of stems per acre will thin themselves out to maybe 100 stems per acre, maybe even down to 60 stems per acre. And that's just the natural process that alder goes through. And so that can be important as we think about managing alder down the road. It likes lower elevations, roughly sea level to 2,000 feet. It can be grown above 2,000 feet, but snow and ice can be a challenge to deal with. It will grow naturally above those elevations, but in general, when I think of managed alder, I try and keep it under about 2,000 feet. Where we find it growing successfully and where we have a lot of good luck managing it, it really depends on where it is on the hillside. So what we're looking for often is the toe of slope, kind of lower down, mid slope down towards the valley. A flat bench, mid slope is pretty good. Terraces, kind of same thing. And again, lower slope, kind of the lower third to half of a hillside is usually where you're going to have a little bit more success with alder. Upper slopes and ridge tops are still possible. You can still grow alder on an upper slope or ridge top, but it's going to be a little bit more sensitive. And some of the other things we look at, it's going to be a combination of factors to let you know how well a given area might work. And upper slope is just one piece, one factor that could play into that. Aspect can be important. Again, this is just another component of your site selection, what'll make a good alder site. East, north, west, or flatter ground are usually considered pretty good, with south-facing slopes or steeper ground usually being a little bit less preferred. Growing season precipitation. So this is rainfall, roughly April through September. So really, I think of it in terms of rainfall through summer. How wet is it? Is it an area that you get your last rains in late April and it doesn't rain again until October, or is it somewhere where you get pretty good coastal influence, or you just get like kind of the Willapa Hills where you get regular precipitation through a good portion of the summer, and so you maintain soil moisture through your growing season. That moisture during growing season can be very, very beneficial to growing alder. And in terms of soils, we're looking for something that's pretty well drained, but not excessively well drained. So you don't necessarily, wetland type sites, really wet, mucky soils that are wet all summer long. If it's a wetland, you're probably not going to be looking to do much in there anyways. But you're also not, you want to steer clear of excessively well drained sites, things that are real rocky or real gravelly, because even if you get that summertime moisture, if the soil's excessively drained, the water will run through the soil before the trees can really utilize it. And then minimal rock is good. That comes down to drainage, but it also comes down to being able to plant the trees. So this is just a quote out of a publication about alder. The availability of water in both the soil and the atmosphere is probably the most important abiotic factor limiting the range of red alder. So it comes back to all of those factors I just discussed on the previous slide, all have to do with water availability. How much water is available in the soil for the tree to use? And in DNR's alder plantings, we found that summertime moisture can be very important. The thick red bars are a way of calculating moisture stress during the summer. It's rainfall minus evapotranspiration, the Penman equation. And the red line is basically the number of trees. It's a surrogate for mortality in our planted stands. You'll see that when those red bars go down lower, like in 2015, it was really, really dry, a lot of moisture stress, and we had relatively high mortality rates. And so soil moisture is really important for managing planted red alder. One thing with future, it's projected to get drier throughout most of Western Oregon and Washington. Doesn't mean that alder is going to be a challenge going forward. When we're planting these stands, they're most sensitive in their first couple of years. So we're still dealing with today. But it just means that going forward, we're going to need to be, we're going to need to pay more attention to where we plant alder. It doesn't mean we're not going to plant alder. It's going to limit us. It just means we need to pay a little bit more attention and be a little bit more careful as things play out. So one of the tools that we've been working on, it was originally developed actually by one of the commissioners, Florian Deisenhofer, and then we've since modified it a bit, just because of some new data that's become available, easily publicly available. And it was originally developed for internal use with DNR, but the hope is to get it published so that it's available for public use, either through the Hardwood Commission or the Hardwood Silviculture Co-op down at Oregon State University. This tool is roughly based upon a paper published by Connie Harrington, Method of Site Quality Evaluation for Red Alder. And really what we did was we took publicly available geospatial data, data on soils, on growing season precipitation, and then topography data. So getting at that, where are you on the slope, how steep it is. And we calculate a 50-year metric site index. And then using those predicted site indices, I've compared that to where we've had success and failures in our own plantings to come up with kind of a classification system for how well will a given area, what's the probability of success essentially for planting in that given area. A lot of the coding work is done, a lot of the data mining and all that is done. It still needs to be field verified. Just in the last couple of weeks, the commission has actually stepped up in a pretty big way and provided me with a bunch of data so we could do the field, so I could do field validation. They provide the field data. I just need to do some statistical analysis to see how well it works. And I'm hoping to get that done here in the next couple months. We're kind of entering a slow season at the nursery, so I should be able to get some time to work on that. But once we get that done and we feel confident with the actual predictive capacity of the model, we'll work on getting it out to landowners. This is just an image of what it currently looks like within our own system. The image on the left is the old model. The image on the right is the new model. And we use some updated soils data in the new model. And then the big difference is growing season precipitation. So getting at that soil moisture during summertime. In these two images, they're the same location, same area. You can see the same polygons are highlighted there. And you know, in some areas, the old model, things it showed is a really good site with the old model still shows really good sites. Some areas that updated soils data and precipitation data may have taken a site that showed as good in the old model and showed as a little less good today. And some areas have actually flopped the other way where it didn't show as being very good, but the new data shows that it's actually better. Again, here's just another image of some places we've planted alder. These, you know, the blue in this image is high quality. It's good stuff. And those hayduke units are alder units that are they're doing really, really well. It's been a very successful site. So it's just an area where it's model predicted high quality, and we've had really good luck there. So we're developing this tool, but this should not be the only piece of your site selection process. So when I think of selecting alder sites, my process, what I go through is I initially do an alder office review. So somebody will call me up and say, hey, I'm thinking about planting alder. What do you think? They'll give me the geographic location. I'll pull up this model. I'll take a look at it. I'll also dig into the soils data, see what the soil texture is, see what the rock component is. I'll look at the topography, either looking at just a regular topo map or LiDAR imagery, or whatever we might have. I'll look at precipitation data and kind of just double check the inputs for the model and make sure that it's not doing anything too weird. I'll also look and see if we've planted anything in the area, see if our neighbors have, and kind of get a feel for the success of those sites. And then also get into unit size and shape, and just to make sure that it makes operational sense when that stand comes to maturity to harvest, to make sure that it's a viable standalone unit. After I've done all that, if it's still, if I don't hit any big red flags at that point, we'll go out and do a field review. And the point of that is basically to confirm that the office data I looked at is appropriate, is accurate, and make sure that things are lining up, confirm operability, and then you'll make sure that the area is delineated properly, and then take a look at what vegetation is on the ground, what shrubs are there in the existing stand before harvest. And shrubs can be a very important piece in understanding the moisture characteristics of that site, what your soil moisture looks like throughout the summer. Something like Oregon grape and salal, those tend to grow on a little bit drier sites. Where sword fern and devil's club, those tend to be found in areas where you have more soil moisture going through the summer. And so these shrubs and plants can tell you a little bit about the soil moisture characteristics during the growing season, which again is really important for successful planting of red alder. Things like grasses, vine maple, and blackberry. I'd say grasses I tend to find more on drier sites, but it's not really a rule. To me, the concern with those three species is more of your ability to control them. Grasses are a big water user. They suck a lot of moisture out of the soil. And so planting red alder into like an old field, for example, if you don't control that grass in some way through disking and tilling or site preparation, you'll have some method for controlling that grass. It can be a big water user, and that can limit water availability for your alder trees. So just some kind of simple red flags and green flags. South-facing slopes, again, it's moisture. It's going to get baked in the sun all summer long, and so that's an area that may reduce summertime moisture availability. Overly well-drained and rocky soils, top of slopes, dry site vegetation, Oregon grape, grasses, those sorts of things. One of these things isn't going to say, if you see one of these, it doesn't mean you can't grow alder there, but it's an indicator that you may have a little bit of a challenge. And so it's just, if you start seeing a bunch of these add up, it may be time to look for another site. But one or two of them, we've planted alder successfully on south-facing slopes and on upper thirds of slopes. But in those cases, it's had other things going for it. It's been a really rainy area, had really good soils, those sorts of things. So the bowls or air dams gets into air drainage. And one issue that's been seen in alder over the years is frost damage from frost pockets. And that's where in the wintertime, cold air flows down the hill. And if it hits a bowl or an air dam, like a wall of standing timber, the cold air can actually sit and you can get freeze damage when the trees are young. And so just trying to avoid, look out for those types of areas and know that they're there, and know that you can potentially have an issue with frost damage. Things that are really good: north-facing slopes, moderately, well-drained, loamy soils, that middle third to lower third of slope, planar slopes, and wet site vegetation. And again, not all north-facing slopes are good, but it's generally an indicator that things are going to be better than, say, a south-facing slope. So a little site selection wrap-up. Site selection is important. In my experience, summertime soil moisture is one of the most important factors. So water matters. And just looking at the soils, looking at the topography, understanding your local weather patterns, those all come into understanding what type of water availability you're going to have. And then competing vegetation. So there's, vegetation can tell you a lot about what the summertime moisture situation might be in your soil, but it also can tell you what you might need to control to maximize water availability for your plant. We use the spatial data. I'm a big fan of using this tool, but the spatial data it's a tool, it's a starting point. It's not an end all be all. Field review is crucial to making sure you have a good site. And then again, competing vegetation can tell you a lot about the site, about the summertime moisture characteristics, but it's also something to be aware of that you're going to need to control it in some way. So understand what that vegetation is, what your control methods might be, as it can be pretty important. So getting to seedlings, once you pick a site, you want to start looking for seedlings, and what you want to buy is going to depend on your budget, what you're looking for, your site quality. Over the last couple of years, actually, I think this past year, all of these plug plus half, plug 6, plug 10, plug 15, and plug 20 seedlings were all available, either on contract or open market. The plug half is, the image on the right is a plug half seedling. It's usually going to be a little bit taller, 3 to 4 feet tall, a little bit thicker diameter. It's going to have a big root system. All those plugs are a 1-year tree. It's going to be a little bit smaller. It's going to have kind of more of that containerized root mass. The image on the left is a plug 15, a Syro 15 alder plug. The 6, 10, 15, and 20 has to do with size of the plug. The 20 is almost getting like a soda can size. The 6 is pretty darn small. When I'm looking at seedlings, I want the root to shoot, so the amount of roots to roughly match the amount of above ground material. So if you were to cut the roots off and weigh it, and then cut the stem, and weigh that, I want those weights to be roughly the same. And that has to do with how quickly the tree will use water and can suck water up. If you have more stem than roots, the tree can lose water out of the leaves faster than it can pull water out of the soil. And so I really like a well-balanced tree. Currently, we're growing 15s and 20s, plug 15s and plug 20s for DNR use. But again, we've used the plug half in the past with good success. One of the benefits of the plug half is it's much bigger tree, bigger diameter, taller tree, and it's more frost hardy. So if you have a site you're worried about frost conditions, that plug half can be a really, really good tree to use. If you're worried about more drought conditions, going to the plug might actually be a benefit. When to buy, I would start calling nurseries pretty quick. We will not have any public alder available this year, but there's kind of in the middle of a national seedling shortage, and nursery space can be really, really hard to find. So I'd start looking around pretty quick. But generally, public sales starts summer and fall. If you call in April looking for trees, you're gonna have a hard time finding trees. Where to buy? Honestly, we call around. If I'm looking for alder to buy for for internal, for DNR use, and we don't have what they need on site, I just start calling nurseries. I'll Google forestry nurseries and see what comes up and start making calls. That's where you're going to find them. Again, we did buy some plug halves and 10s or 15s on the open market this summer or this winter. There were some 6s available as well, and so there are some nurseries growing them. And then when to plant, we're usually looking to plant alder after the last hard freeze. So generally April or so is kind of a good time to get going. You don't want to plant too late though. You want to be after the last hard freeze, but before the rain, well before the rain ends. So April is usually a pretty good time frame. After planting, you want to control competing vegetation. Again, it goes down to that moisture situation. You want to make sure you give those plants as much moisture as you can. Manage density. If you end up with some mortality, to go back in a year later and plant a few more per acres. We do it. It happens. And then if you get, as the trees grow and they mature, I think Andy and Glenn may talk more about density management later and financial viability, but making sure you end up with the stand you want. If you plant 600 stems to the acre and all 600 survive, at some point you're going to need to thin that out so that you get the log quality you're looking for and the growth you're looking for. And one of my favorite things to do is to just watch it grow. Alder grows super fast. And it's really fun to see how quickly those trees develop and how quickly they grow. You'll take something that's bare ground and then you'll plant it in a few years, it's 10 feet tall, and it's really impressive to just watch it grow. In terms of landowner assistance, couple resources here for you. WSU Forestry Extension, Southwest Washington and Puget Sound regions. They've got some great resources and great people. Within DNR, we have a small landowner assistance program, and they can provide some pretty good resources for you as well. And then if you're down into Oregon, the OSU Forestry Extension, they have some great resources. Glen Ahrens is an incredible resource for Alder, and they'd be happy to help you out. And last, that's it, I guess. So thank you. That picture was taken this morning. That's some of the Styro 15, the Plug 15 Alder we're growing that's going to go out to the Olympic Peninsula next spring. Thinking about how quickly these alder trees grow, those are pushing, I think, 12 to 16 inches in height. And that seed was sown, I think, about a month and a half ago, maybe 2 months ago. So it grows fast. Thank you.
Great.
Brian, we do have a question. What about storm damage over the life of the plantation? How many of your sites escape storm damage?
We have some storm damage issues. I would say it's not terrible, but we do occasionally have some storm damage issues. Generally, more coastal areas, you're going to get hit with wind a little bit harder. Ridge tops, you might get hit with wind a little bit harder. And higher elevations where you might get more snow and ice type damage can be a challenge. But I would say in general, storm damage isn't a major issue for us. It happens, but it's not that. From my experience, it hasn't been a major problem.
Great, thanks, Brian. Our next speaker is, to segue from Brian's comment, our next speaker is going to be Glen Ahrens, speaking of Oregon State and Glen Ahrens. And Glen is going to talk about growth and yield modeling for red alder stands, both managed and maybe a little bit about unmanaged stands. Glen's an assistant professor and an extension forester with OSU, Go Beeves, in Clackamas, Marion, Hood River counties, and he's the director of the Oregon State University Hardwoods Silvicultural Co-op, also known as the HSC. He'll highlight the results of the HSC's work on measuring and modeling the growth and yield of red alder stands. And the study itself has been going on since 1989. There's 26 established plantations in Oregon, Washington, and British Columbia. Glen, welcome, and thank you for joining us.
All right, thank you, Joe. Brian, yeah, there we go. I need to share my screen, so I'll get started with my presentation. And assuming I can find it. Okay. Well, where did it go? Sorry about that. It's up on my computer, but it's not showing up on the. So I'm going to start over again. Zoom never seems to work perfectly, does it? All right, there it is.
Yep, we got it. Thanks, Glenn.
Okay, thank you. All right, you can see that okay? All right, well, thank you for the opportunity. It's good to see you all again at the annual Hardwood Commission Symposium. And I'm just gonna follow up, actually. We talked about our growth and yield results last year. So I'm gonna review these results again and give you an update on where we're going. Just review briefly about the Hardwood Silviculture Co-op. Currently have these members here from both public and private agency, state agency, private landowner, and also hardwood mill production, Cascade Hardwood in Port Angeles Hardwood. So we have a good diverse group of members supporting this. As Joe said, this has been going on for more than 30 years. So we've got some well-developed alder plantations that we're using as a basis for understanding the production and management of alder. A series of 26 installations that we established starting 1989 and through 97, covering a range of spacings and different kinds of thinning treatments, really just trying to understand the response of alder to management, characterize the options and the growth and yield. Focused on the growth and yield, our data from all these installations goes into a growth and yield model. We're working with David Hann and the Center for Intensive Plantation Silviculture at OSU to develop the basic model that we can then use to make yield tables that we'll describe later. This shows you the distribution of our plantation sites from Southern Oregon up to British Columbia, and also shows which ones are the better sites. So the orange and red are the highest productivity, and the yellow and the green are lower. And I might note that growing alder too close to the saltwater tends to be the lower productivity sites. So you're looking for some of those sites a little bit inland. And definitely Brian gave a great review of the site selection criteria, and that's essential to really focus on picking good to excellent sites for good performance. So we call this our RAP Organon, or Red Alder Plantation Model, and Organon is the name of the growth model that David Hann developed. It's just a great way to take the kinds of data we generated and predict the development and growth and yield of trees. Working with them this last year, kind of what I said last year was the next steps were getting our older stand data. So we have data from 22 and 27 year measurements, and we were working to update that. Doug Mingwaren got a good start on that over the last few years. And this last year, Dave Hann really stepped in and really kind of started over again with refitting all those equations, as he was the author of the original Organon, which actually did kind of take a fair amount of time, more time than I expected. But he's just about done with a refit of all this, especially looking at the growth and the mortality, the natural self-thing that might occur. One of the things that we found over the last sets of measurements with this older stand data is that we're seeing more mortality than we would expect, and we're seeing some of the sites are having some issues, so it's sort of affecting this refit process, and part of the reason it took a little more time. We're going to have to see what those results are. We don't have the final results yet. But basically, we've already taken the previous iteration of the model and actually just taken our data from our older installations to give a snapshot of what the yield tables should look like. And I presented some of this last year, but basically we took sites from high, medium, and low productivity amongst these plantation installations, and then we just projected them just a little bit further to more rotation age. And just as an example of what a yield table would look like, particularly looking at those management regimes that make sense. Generally with alder, we usually look at planting around 500 trees per acre. Certainly there are options to plant as few as 400 trees per acre, but in our studies we covered a range from a low density to a high density. So if you look at the kinds of yields that we expect from high productivity sites, picking those from our installations and projecting them forward, looking in that range of 15 to 20,000 board feet per acre, with some of the kind of operational management approaches, like even just planting 500 trees per acre on a good site, it does quite well even without thinning, because they grow so fast and they self-thin pretty well. But thinning generally ensures that you got good growth and better tree sizes and obviously log product sizes. Even planting only 250 trees per acre on a really good site, you can do well, but that's kind of risky because that's not quite enough trees to really ensure you get good establishment. With medium sites, we're more in the range of 12 to 15,000 board feet in a 30-year rotation, and maybe go a little longer to get towards 15,000 board feet or more. This is for 5-inch and up saw logs. But this is an example of what that looks like when we finish the model. We really want to create a full set of these and work with users as to what they'd like to see in growth and yield tables, and also in using the actual yield model as a tool. But when you look at these results, in general, what we've seen in our plantations is they do perform, on average about 25 to 50% better than the normal yield that was characterized actually by the DNR in the old days by Chuck Chambers, who did a full set of empirical yield tables for the major species in Washington. And so with planting and management, we certainly do better than just with your average natural stand. And of course, the reason that we thin alder, as Brian said, alder tends to come in very dense. So if you're managing alder that you didn't plant, you really want to be spacing them out and making sure that they can capture that rapid early growth that they have, that they're not overcrowded and spending all their energy killing each other in the first 10 years. But when we plant at a nice spacing like 500 trees or 400 trees per acre, they really grow well and jump out of the ground, and their diameter growth is good. But thinning then down to more like 200 trees per acre, or a range somewhere between 180 to 250, you're definitely going to increase the yield of the larger logs. And of course, the values are much higher for larger logs. So that's where you get a real gain from thinning. If the stand is not growing quite as well in diameter, you want to ensure that it grows well in diameter by thinning them out early. And of course, there's a whole another presentation about the silviculture of alder that I'm not giving today. It's focused on growth and yield. Our next steps are to finish with the refit that Dave Han is finalizing, and really make that new model that Andy Bluhm and you'll hear from Andy next, that we can work with to generate a full set of growth and yield tables, and include that with our basic management handbook for alder in a more of a kind of a printed and user-friendly version. And also it's important that we want to be able to help clients use the model. Certainly Brian and others at DNR in their technical forestry folks can use the model themselves and put their own user input and their own site selection and plantation management scenarios to do that and project yields. Another important next step in what our hardwood co-op is working on, we're considering genetic improvement. So in terms of yield, we certainly have some good results from some of the early clone development, and also just selecting and breeding superior trees. There's a lot of gain that could be made with alder, and we do have clonal material that we're working with that has some promise for that. And so that's something else that we're looking at for the future in the hardwood co-op. This is actually a 16-year-old alder plantation that Florian sent pictures of the other day, just to show how well a plantation does on a good site. And I know that both Florian and Brian are pretty intimately familiar with this site. But basically, for managing alder, the future of alder production, sustaining the resource is going to be the working forest on uplands, and our tools and products from the Hardwood Silviculture Co-op, the growth and yield model, the yield tables, and basically the alder management handbook, are going to be essential to support the folks that want to manage, the landowners, land managers interested in managing alder in those working forests. And so one thing I'd ask is that we're looking for input from foresters and landowners on what would be useful to you as we prepare our yield tables in our handbook. And also we're here to assist you with using those products. And anyone who has questions about managing alder, even current time, please get in touch with us at the Hardwood Silviculture Co-op. That'd be myself or Andy Bluhm, who will be speaking soon. So we're happy to help with you with your alder questions and other hardwoods as well. So if there are any questions.
Glenn?
Yep.
Glenn, this question came in at the end of Brian's talk, and maybe you can answer this.
Yeah.
After 1 to 2 months of growth, getting 12 to 16 inches of growth, any reason why those seedlings could be sown in late January, early February, and planted in the spring?
Well, that's a good question. That would be a question for someone who grows in a greenhouse. Brian, do you have an answer for that one? Not sure if Brian's there anymore. You know, we haven't done that, and I think that there's some challenges with getting a good quality seedling. You know, they do in the greenhouse, they will sow usually more early, like in March, and then they'll at mid-season, they'll transplant to a nursery bed to grow a beefier seedling. But I'm not familiar with trying to do an early greenhouse seedling that could then be planted that same spring. It's not something that we've tried or tested.
Okay, maybe Eric, you can get hold of Brian or get hold of me, and we can get that answered for you. Another chat. There is more self-thinning at higher altitudes. How does this affect the choice of hardwood over softwood?
You know, the choice of hardwood over softwood in general goes back to what Brian was reviewing and what we learned the hard way over many years is that you really need to understand your site and its growing potential for alder. So even if you are pushing the elevation, Brian suggested below 2,000 feet, we have some of our study sites up, you know, more like 2,500. I've seen it planted up at 3,000. So it very much depends on the site specifics and what alder we expect to do in that site. You know, if you have a favorable microsite and it's not a cold air drainage, not a heavy snow zone, I'm not sure what you mean by self-thinning more at higher elevation. I mean, self-thinning generally proceeds based on how crowded a stand is, and then how well the winners and losers sort of differentiate in the crowd. So that's often quite variable, just depending on those, you know, the specific site conditions.
He came back and said, "Now we have a lot of questions here, and we'll
Coming
have
in the chat, huh?
and get them back." Okay.
Well, certainly I'd be concerned. I wouldn't recommend growing alder at higher elevations, above 2,000 feet, unless you have reason to believe it's a particularly good site.
And were 30-foot logs used to calculate the volumes you showed?
Yeah.
Okay, that answers that question. Now we need to move on.
Okay, thank you.
Thank you.
Thanks, Glenn. Thanks, Glenn. The next speaker is on Glenn's screen there is Andy Bluhm. And Andy's also at Oregon State. He's the Associate Program Director of the Hardwoods Silviculture Co-op, and he's a Senior Faculty Research Assistant at OSU. He will also discuss the Organon growth model and its applications to a net present value calculation of a program of red alder versus Douglas fir. He's got various management regimes to be able to put as an input, as well as site qualities, and of course, variable interest rates. So Andy, I will turn it over to you.
Okay, can you see my screen here?
Yes, looks good.
Okay, so let me let's do the slideshow here. Do you see just the slide? I can't tell.
No, it shows the directory on the left. Yeah, if you if you push that button, there you go. I know one of those buttons.
Right. Okay.
Perfect.
How's that?
Perfect. Thanks.
Okay, great. All right. Well, thank you very much. I'm, as Joe and Glenn indicated, I'm Andy Bluhm. I work with Glenn and with the Hardwood Commission and the DNR on and off for the past couple decades here, studying red alder and the silvicultural techniques and growth and yield, all aspects of red alder. And today I've been tasked with providing an economic comparison between red alder and Douglas fir. I decided to also throw in hemlock, by the way, too, for today's talk. And these economic comparisons are super valuable. All types of agencies, organizations, and even just general landowners have to make decisions on what they want to do based on, what kind of return they're going to get. These are daily decisions in everyday life, and these companies and landowners face it as well. So they're very important for deciding on our courses of action, what to take, what to manage for, when to cut. There's a lot of decisions involved. And so how those decisions affect the economics behind your actions is critical for deciding on your course of action. However, with forestry, it's a little trickier to do these economic comparisons for multiple reasons. The main reason is that, many times when you decide to plant a unit, you're not going to see any economic return for 30, 40, 50, 60 years. So it's really hard to kind of get a handle on what the conditions in the markets and what everything's going to be in that length of time. So these comparisons always have these assumptions built into them, and they use past data and whatever current tools we have to make these predictions. Therefore, and I know I'm not speaking anything new here, all these economic comparisons are very dependent on the assumptions you use, and there are no right answers when you talk about these economic comparisons. They yield a lot of different answers, and it all depends on the tools you use and the assumptions you make. So many comparisons may not apply to individual landowners and those specific objectives, their management regimes, their land base, whether they need to answer to shareholders, whether they need to answer to or abide by state governmental laws, restrictions, et cetera, et cetera. So many of these comparisons have limited usefulness in applying them to your actual individual circumstance or your individual acre. However, they do provide very useful information if you're talking about generalities, and allow you to hone in and change a lot of these assumptions to fit your own needs. So that being said, let's go into some of the assumptions that I used in this analysis. This is a very, very general comparison. I tried to get a regional wide snapshot of growth and yield for these species across multiple ownerships and what we consider common management regimes. I'll get into that in a minute here. But like for Douglas fir and hemlock, the values I got for both the high site and the low site harvest yield and rotation ages are based on surveys that I did when calling around and talking to DNR foresters and other foresters that manage red alder, both in Washington and in Oregon. I tried to get some general numbers and then tried to harvest yield and rotation age numbers, as well as what's the common silvicultural regime used and the costs associated with those regimes, and tried to come up with an average, kind of a general scenario. So it's the assumptions used for Douglas fir and hemlock are really regional based and really broad brush look at what kind of silviculture and costs are associated with that. I also threw in something that's a little unique in the fact, because down here in Oregon, especially in a lot of the Douglas fir zone, there is along the coast Swiss needlecast. And Swiss needlecast is causing various amounts of growth reduction in Douglas fir, which prompts the question of whether to keep managing Douglas fir or to move to an alternate species. And the two most common alternate species in this scenario would be both red alder and hemlock. So I threw in there what your Douglas fir yields would be in Swiss needlecast zones using a 30% volume reduction. So unlike Douglas fir and hemlock, for red alder, I took the Hardwood Silviculture Co-op stand data from our stands, the HSC stands that are greater than 22 years old, and I grew that stand out using, like Glenn mentioned, the previous iteration of the RAP Organon growth and yield model. I binned those into a high site and medium site classification with, it turned out to be about 4 or 5 sites per site quality calculations. Then I averaged it, all the harvest yields and rotation ages, and then put all of that into an economic calculator, which then spat out some of the economic variables that we're interested in. You'll notice that the rotation ages are variable for the red alder scenarios, and that's because I used a rotation age where net present value is maximized. And finally, then for all species, I had to make a whole bunch of assumptions on the costs associated with management, all the different management regimes, what the planting densities were, what the piece, if and when they pre-commercially thinned, all of that stuff. So merchandising specifications, I had to make assumptions on that, et cetera, et cetera. So there's a lot of assumptions in the costs associated with these comparisons. Finally, I took those yields and rotation ages and costs, and then had to apply log values. And I just used the 10-year average of the log prices that are posted on the DNR website. Then I had to apply a guiding rate to these comparisons, and I used 5.5%, which is kind of an average between some of the public agencies' guiding rates and some of the private companies' guiding rates. So I had to qualify that because there are a lot of assumptions that go into this type of analysis. And here's kind of what I came up with. You can see that for Douglas fir, we have a high site and a low site scenario. And then the third scenario is a high site with Swiss needlecast present. For red alder, the scenario is a high site and a medium site. And for hemlock, I used just a average kind of medium site hemlock. This row here shows your harvest yield in thousands of board feet. Here's your rotation ages that you get. Like I said, these rotation ages for Douglas fir and the rotation age for hemlock are just kind of average of what general foresters around the region came up with, whereas these rotation ages are based on max NPV. You apply all these costs and yields and rotation ages, and you apply the guiding rate, and you come up with 3 very commonly used economic indicators of your scenarios. The first is net present value. Second is internal rate of return. And the third is bare land value, or kind of soil expectation value. They're kind of interchangeable in a way. And we'll start with net present value. High site Douglas fir, $750 an acre. Low site obviously is lower. And then when you take that 30% reduction in volume in areas where there's Swiss needlecast, really low NPV. Those scenarios translate into these different internal rate of return values here, and also then show what your bare land or soil expectation value is. So it makes perfect sense that your high sites have greater values here than your low sites. And then when you take a 30% hit, that's what you get. It's much lower. Let's look at, sure, we'll look at hemlock next. You can see the same thing. You see that these values of net present value, internal rate of return, and bare land value are much lower. And that's largely a reflection of the lower log prices. Growth rates, yields are really high. Ages are a little bit longer, but essentially these kind of low values here are generally because of the low 10-year average of hemlock log prices. Now, red alder, high site and medium site. These are values projected from Organon with your harvest yields. These are the rotation ages where NPV is maximized. And then once again, you get these three values. The red alder high site scenario yields a internal rate of return of just above 8, which is greater than any of the internal rate of returns you get for any Doug fir scenario, and a bare land value of over $1,000, which is also greater than any of the Douglas fir scenarios. So red alder on high sites using these assumptions compares very favorably to any of the management scenarios I used for Douglas fir. However, when you get down to a medium site, you can see that these yields really drop off and the rotation age increases. So therefore, you end up with a lot less favorable economic indicators. In fact, it's even lower, but relatively favorable to areas where, Douglas fir is infected with needle cast, and still a little bit greater than what your hemlock numbers are. So this isn't the right answer. There is no right answer when you do these economic comparisons. There are 1,000,001 different ways to conduct these, and it all depends on all the assumptions you use and your data sources you use and your tools you use. However, hopefully this gives everybody in the audience a good indication of some of the relative rankings or how these different species and different site qualities and management regimes compare against one another. The actual economic comparison on a given acre is much more difficult to determine, but can be done. So this is the type of results that, coupled with Brian's information on how to tell the sites apart, and with Glenn's information on these harvest yields and rotation ages and stand tables, if we start putting all the pieces together that we've been working on together through the years, you can end up with results like this that actually can help guide management decisions for both agencies, industry, and private landowners. So I know there'll probably be a lot of questions, and of course, all the devils are in the details here. But that's what I have for now, and hopefully that gives everybody a broad brush look at some of the economic comparisons between these species. So
Okay.
with that,
Andy, we have one question. Are you still on?
yeah.
Yeah. Okay. And then we're going to forego the break and just continue on because we're a little bit behind. I have a 30-year-old alder stand on a good, excellent site is ready for harvest. The understory has a substantial component of 15 to 20 foot hemlock. On a strictly dollar basis, would I be better off managing for hemlock or clear all and grow either alder or Doug?
Well, I'm a little confused on the question itself.
Let me send you the question and you can answer it.
Okay.
All right.
Oh, I can see it right here. Okay, I clicked on it. Well, what I'm wondering is, it would make no sense to just cut all the alder right now, a 30-year-old alder stand, and just go for the hemlock. So I hope he's not or hope the yeah, I hope Steve, I hope you're not wanting to do that. So I would not manage for the hemlock right now. I would manage for the alder.
Okay, do you see the other question there?
Yes. So there's been a lot of
Here's a question that others maybe not see. How do you think Western red cedar would work? How do you think Western red cedar and alder would work?
yes, so there's been a lot of interest in mixed species plantations in the region. And there's also been some really good work and really a lot of interest in looking at like these two-storied stands where you don't have the canopy of mixed species, but you have one canopy layer of alder, and then you have a shade tolerant species such as Western red cedar or hemlock in the understory, because that seems like that's a scenario that could potentially work. And the numbers, the research on that is, the anecdotal evidence is relatively solid, but the economic numbers and the experimental results on that are still kind of preliminary. Let me just say that the first factor is whether you can do ground-based harvesting or if it's a cable show, because if you do these two-storied stand type management scenarios, removing the alder without damaging either the hemlock or the Western red cedar understory is critical, because you'd be damaging the next crop. So if you can get in there with these machinery and get your alder off of there without doing too much damage of the cedar and the hemlock, then I think these two-storied management scenarios are entirely feasible, because you have a 15, 20, 30-year head start because you already have your next crop in the ground. So this is a very attractive and very applicable management strategy in areas, but not across the landscape. So we're working on these studies, and there's been some studies that have been put in the ground that show that this is a viable alternative.
Thank you very much, Andy. We appreciate it. Joe?
Okay, thanks, Andy. We're running a little bit behind here, so we're going to skip the break and go right into our next presentation. This is going to be an update from the UW's long-term studies in the Olympic Natural Resources Forest or unit out on the Forks area. Bernard Bormann is the director of the Olympic Natural Resources Center, and he's a professor at the UW. I still call it the School of Forestry, and I will continue to call it the School of Forestry. And he will be discussing the results of the long-term ecosystem project that includes red alder's contributions to forest health and growth, beneficial changes to the soil productivity, and wildlife habitat. Welcome, Bernard. Thanks for.
Yeah, thanks, Joe. I really appreciate it. And hello, everyone. Very nice to be with you today. I'm going to jump right to my presentation. Let's see. It does not look right. Are you seeing my presentation?
It looks like you got a picture of Yellowstone National Park there.
Okay, no, I picked the wrong box. Hold on. Oh, that's my desktop. Ah, here it is. There we go.
Yeah, I see that.
And okay, so now I'm going to turn that to, is this looking, do I need to switch my screen, or is this good?
If you could enlarge it a little bit, it looks like it's showing the current slide and the next slide.
Okay, I need to switch my screen. Hold on. How's that look?
Perfect. Thanks.
Okay, great. Yeah, I'm here to promote resurgence of red alder in the Pacific Northwest. We approach at ONRC, we've developed a sustainability framework we call ecosystem sustainability, where we're trying to put community well-being and environment well-being on the same playing field and focus on learning to drive sustainability through time. I'm going to just very quickly go through and talk about some contributions that red alder can play to sustainability. I'm not going to have time to talk much about the community well-being part, but so I'm focusing in on environment, and I will get into two studies that are being planned and underway, and end with a 1933's moment at Wind River. So you're all probably familiar with this graph, which is the site index curves for various species in the Northwest. And one of the first questions I want to ask is, can alder sequester more carbon in the next, if you were planting alder today, could you sequester more carbon in the next 25 years than you would if you were planting Douglas fir? This is an important question. And we don't know the answer very well, but it would appear as though there's some significant possibility of that given the growth rates. And this doesn't take into account the effects of alder on soil and the growth of other species, which I'm going to dive into next. So this is a graphic actually from my master's thesis in the late 70s, done on Capitol Forest in a sequence of red alder stands looking at how alder was infecting soil nitrogen content. And this is it's pretty amazing, and it really needs to be put into proper context. Studies that followed this one, if you look at and average those numbers for year 50, you get up to, this pretty much confirmed what I saw back then. Just pretty remarkable, 2,000 kilograms per hectare in pure and somewhat less in mixed. The context you need to think about is this: what's a typical one-time nitrogen fertilization for Douglas fir in the Northwest? And it's down there at 200 pounds per acre, which is where this arrow is. And if you did fertilize, you're not going to see that nitrogen show up in the mineral soil. So this is a phenomenal amount of nitrogen being added to these systems. Less well known is the effect of alder on mineral soil organic matter, or total soil organic matter. Soil organic matter is hugely important, particularly with changes in climate and drought problems. So here's one of the best studies to show the difference between alder and conifer was done back actually in New Hampshire with conifers and alders in manufactured mesocosm soils where the soils were identical in the beginning. And the results that occurred, first of all, the litter carbon was significantly higher in alder compared to conifer. You need to note that the difference in the quality of the litter is really big as well. But this is not the story. The real story is what happens in the mineral soil. And young conifers, and Douglas fir in particular, and then we have other studies that corroborate this conclusion, can drive down the soil organic matter content in the B horizon. The B horizon is brown and reddish because of that organic matter, and most of the nutrients in the B horizon are associated with that organic matter, and so that organic matter declines while the conifers are accessing the nutrients within them so that they can grow well. This doesn't happen in alder. The alder can actually increase that mineral soil organic matter content. Huge, and it's just a tremendously obvious result. Here's an even less well-known effect of alder, but I think perhaps even the most important of all, and that is its ability to extract nutrients out of rocks. Now, you've all seen alders growing on logging roads, and this is a study that looked into that. We were able to grind up basalt, filter it out. So we had like 1 millimeter particles, mixed it with perlite, added alder seeds. So we have, going across from left to right, we have just that mixture of perlite and basalt, or perlite alone down below, with just alder seeds. Second one is put in alder mycorrhizae, still no effect. But when we add the nitrogen fixing bacteria Frankia, the alders with the basalt grow like very readily, and even more so with both Frankia and mycorrhizae. Now, this is important because those rocks actually are the source, principal source of all the other nutrients other than nitrogen. The cations, calcium, magnesium, also phosphorus, are coming from those rock particles, and that is why these alder seedlings are growing well. That's where their nutrients are coming from. And just secondarily, the process of weathering, the chemical reaction of taking silicate rock and converting it into nutrients and other products, consumes CO2 from the atmosphere by itself. It's in addition to the photosynthesis. And lastly, my point is we've actually looked at other species. Pines can do this but to a much lesser degree. Alder is clearly the most active weathering species we've studied. So I'll just mention very quickly, there's a growing concern about early seral conditions in the Northwest. There are some very prominent papers out that have raised this issue. The kind of natural post-disturbance forests have become very rare, because particularly if you do not count in heavily managed Douglas fir monocultures, industry's gotten too good at growing these and getting rid of its competing species quickly. Federal agencies, of course, have chosen to focus on late seral conditions. So there's a very clear and significant decline, principally in the coastal parts of Oregon and Washington, where this decline is happening. And there's a whole new body of work emerging showing very distinct drops in species associated with this seral stage. There's a number of neotropical birds in major decline. Insects, what worries me the most, also major decline. Insects are the basis for the food chain for many birds, but also for fish. And so, and of course, deer and elk are early seral associates. Growing alder, more alder, would help to address this question. So let me quickly turn to an exciting new study that we are just about to start implementing on the Olympic Experimental State Forest. We call it the T3 Watershed Experiment. DNR has allocated 20,000 acres or 16 watersheds to do this. We're going to be comparing 8 different stand scale, operational scale prescriptions, 2 of which have major alder elements. And I'll just point to those on this picture. The first one is a riparian alder prescription. So the OESF, the experimental forest, has given us, was developed to allow us to go and test things, and we're going to go right into the riparian zone and thin the conifers that are there very heavily down to 30 or less trees per acre, which it will open up those stands enough so that we can grow repeated alder rotations with the hopes that litter from the alder and the insects associated with this will increase fish populations that we will be monitoring. Secondly, right above upland from this riparian zone is this alder cedar polyculture that Andy was just describing a minute ago. In fact, he was one of the principals, along with Brian Morris, to help develop this and include it in the study. These stands will be harvested. This is this picture you see is 40 to 50-year-old Douglas fir, mostly hemlock now plantations on the truss lands. And I'll show you where in a minute. The idea is to mix cedar and alder in different proportions, so we have a variable composition across the landscape, but at the same time do a study. So we will compare the various mixtures. This actually, Andy was talking about some studies that have been done at a very small scale. This is the first operational attempt at looking at this. And the idea is you grow the alder for 35 years. You take out whatever alder you can get without hurting the cedar, gives you access to the riparian to get the alder down there. And then you replant with alder and come back at 70 where you can harvest both the cedar and the alder. It seems to solve a lot of problems. Ecologically makes a lot of sense. This is where these experiments are going in, these particular watersheds out on the Outer Peninsula and the Clearwater, Hoh, and near Kalaloch. Second study I want to tell you about is long-term ecosystem productivity study, particularly the one at Mount Hebo, which kind of set up the previous prescription I just talked about. This was initiated in the 90s, 25 years old. And what we did, now I'll talk about three of the treatments. So there was a control, which was just to allow the post-fire plantation created in the 30s to continue on its own. Second is to do this very, very wide thinning to 30 trees per acre residuals and underplant with alder. A third one was to underplant with conifers. What do we see? The alders are a little bit bigger than the understory alders, are a little bit bigger than the understory conifers. So they're both doing okay. But what really strikes you, and the biggest result from the study so far, is that the residual trees, the residual Douglas fir, have just responded phenomenally to having this association with alder underplanting. And the basal area increment is over twice as big as the similar trees in the control, 50% larger than the conifers, than those that have conifers planted underneath them. So if you want to grow, if you want to produce larger conifer trees, this system looks like it's working really well. If you want for either putting in the stream or for other purposes, food chain potential looks great. But most important, if we can come up with a system to apply in riparian areas that makes sense ecologically and economically, we might be able to actually increase the land base instead of decrease the land base, which is what we've been doing for the last 30 years. Lastly, I just want to end on this 1933 moment at Wind River. So this is an air photo, I think from 96. And you can see this big green stripe running down the middle of this picture. That's a very interesting historical phenomena. This whole area was burned heavily in 27 in the Yakult burn. 29, they came in and planted Douglas fir from, most of these trees you're looking at were those that were planted in 1929. There was a crew member in the planting crew who was wondering about this and bet the silviculturist there that if we planted alder here, it would have stopped the fire. Turned out that forester was Leo Isaac, one of the earliest silviculturists in the Northwest, and he went over to the Wind River Nursery, had them grow some alder, and they came back 4 years later and planted alder in between the Douglas fir that they'd already planted. And this was not the best seed source and various other problems. And the alder grew for 30 or 40 years and eventually was pretty well overtopped by Douglas fir. The interesting thing was Bob Tarrant, who I hope all of you understand the importance of this one individual, happened by accident to run into this strip and noticed it and went back, looked into it, found out its history. Some research was done by people like Dick Miller, and they projected big Douglas fir site index changes. And I'm going to show you in a minute what's happening in the Oregon Cascades, the Western Oregon Cascades, and where we're basically starting over. But before I do that, I just jumped over to Google Earth to take a look at this strip, and these trees are still growing pretty darn good, which got me to get my GIS guy to download the LiDAR from the area and give me a strip across across the alder strip, and this is what we're seeing. Those trees that had 20, 25 years of alder, those Douglas fir trees are up to 140 feet tall. On either side, the trees are between 60 and 100. You know, it's just a phenomenal effect. This sort of thing needs to get into those net present value calculations somehow. And this is what happened down along the McKenzie River. I was there last week, took this picture. This is another long-term productivity experiment site of a 25-year Douglas fir plantation. Not one Doug fir survived in that treatment, not one. And the tree tags are all gone. We see rocks where the surface of the rocks exploded in the fire, leaving patches where there's just rocks on the surface. Just unbelievably hot. What is Weyerhaeuser? So next door to this is the Weyerhaeuser Tree Farm. What are they doing? They're planting Douglas fir wall to wall. It's the same day. The day is repeating itself. They're doing Doug fir wall to wall. Well, it turns out we have next to these plots, we have a plot we put in that's a mixture of red alder and Douglas fir. And what happened in the fire there is fascinating. So some of the Doug fir actually survived in these plots. The alder is actually leafing out, which is, I think, short-lived because a lot of the base of the alders were killed. But take a look at these pictures on the right. So the alder, this upper right is an alder that was killed. The bark has very little char. The aluminum tags are pristine. There's even moss on them. Right next door, and this is like 5 feet away, is a Doug fir where the tag, I mean, this is one of the only Doug firs we found a tag on, and this tag was half melted. So the flammability difference between these two is huge. And somebody ought to really be thinking about whether or not you want these kinds of stands on the landscape. The fire, by the way, went into the mixed stand, did its damage, and then stopped. It did not travel on the other side. And we have 4 of those stands where the same thing happened. So it seems like it's time to start looking at alder for that purpose. I'm going to end with this slide. So people are talking about natural climate solutions. There's big money flowing around about that. And I think it's time we try to sell alder into this natural climate solution idea to really help revitalize the communities and environment through carbon sequestration, increased soil productivity, particularly after fire. You know, we talk about regenerative agriculture. This is regenerative forestry, reverse declines in major and early cereal plants. Think about diversifying the landscape. I don't know why there isn't 15% of the landscape dedicated to early cereal or stands with early cereal elements. But to do this, we need money, because the money to just follow up on some of these ideas is not available right now. The Forest Service no longer supports the long-term productivity study. There's almost no money around to do this. So we're working, trying to find sources of funding. We'd love to see a major push where we could do something like build on the OSU co-op, bring it up to Washington, go further. So that's my dream. At any rate, that's the end of my presentation, and I will turn it back to you, Joe.
Bernard, very quickly, we have a question. How many acres of alder are going to be planted overall? I presume he's referring to the experimental.
If it's a Weyerhaeuser tree farm down there, no one mentioned that they were going to plant a single alder. In terms of the study site that got burned, we are hoping to redo the study treatments, but that will take some work with the Willamette National Forest to make that happen. By the way, those alder stands were at 2,000 feet in the Oregon Cascades. People didn't think alder would grow well there. They grew fantastic. It was a beautiful alder stands up there.
Thank you, Bernard. Appreciate it. Joe?
Thanks, Dave. Bernard, thanks again. And it's an interesting perspective on the role Alder can play in both carbon sequestration and fire protection. We have a guest speaker, and I apologize, Representative Springer, for delaying your start here. But Larry Springer is the Deputy Majority Leader of the Washington State House of Representatives. And a key ingredient to his position is he's a member of the state's Rural Development, Agricultural, and Natural Resources Committee. So welcome to our symposium, and maybe we'll see you at some other ones further down the road here. He's going to update us on what happened this session regarding forest practices. And if I am reincarnated, I do want to run a wine business too. So thank you.
Well, I'm always looking for part-time help, so come on by.
Yeah, there you go. Well, I'm semi-retired, so that sounds good.
Thanks for having me. And don't worry about being a little bit delayed. I was fascinated by Bernard's presentation there and how the consideration of alder or other species that might help mitigate fire damage or help prevent it is something that's near and dear to my heart, in as much as my primary piece of legislation this last session was House Bill 1168, which you may be familiar with. It is the Forest Health Wildfire Bill that passed actually unanimously at every turn. I think it had 2 no votes in committee, but other than that, the House passed it unanimously, the Senate passed it unanimously, the governor signed it. I'll quickly just go through the elements of that bill and how it might tie into your conversation here. The bill essentially appropriates $125 million per biennium ongoing. That money will be used to really do 3 things. Number one, to upgrade the Department of Natural Resources equipment inventory for wildfire suppression. That means more dozers, more water trucks, replacement helicopter or 2. The 2 helicopters the department is flying right now, both flew in the Vietnam War, and they are on their last legs. I don't think I would want to fly on one, frankly. So a large portion of that revenue that's generated will go to increasing their equipment and being able to pre-position equipment in anticipation of fire season. It also hires about 20 to 30 new full-time firefighters and forest health workers for the department. So that's sort of kind of the capital end. It also sets up a number of advisory committees to help the department determine what kind of forest health initiatives should be taken over the next 20 years, which is where I think Bernard's presentation might be of interest to those advisory committees. The large and small forest landowners are a part of those advisory committees, so I would encourage you to take a look at those and see if there's some application there. The second part of the bill is to essentially help in the way of grant money communities that are at risk for wildfire damage, to make them more resilient, more protected, and better able to withstand wildfire. As you probably all know, the small community of Malden, south of Spokane, 80% of the town was literally burned to the ground in 3 hours last Labor Day weekend. It's not a wealthy community by any stretch of the imagination, and they need help. So this will help some of those types of communities. There will be an inventory done of those communities that are most at risk. Number 1 on the list right now is Roslyn, outside of Cle Elum. Leavenworth actually has significant risk as well, and other communities. And then the third part, which I think is the most important from my perspective, is an attempt then to identify those areas of forest and grassland that are most at risk for devastating wildfire. And then sends those crews that got hired in the first part of the bill into those areas to help make them more resilient. In the case of forests, that means thinning, selective logging, controlled burn of underbrush, getting sufficient distance between the crowns of the big trees, and then creating what we call community protection zones, which is a semi-fire break. It's not we don't scrape everything right to the ground, but you thin pretty strictly and create a bit of a fire break that will at least slow the fire down. For example, my wife and I, we have a cabin over by Lake Wenatchee, and we had a level 2 fire, level 2 evacuation a year ago, because it's a fire like less than a mile away, and it was burning in an area that hadn't burned in over 100 years, and the fuel load was astronomical. So it's those kinds of locations that we'll try to get in and clean up. So that's essentially the bill. It's going to take a while. It's a long-term investment. It's a 20-year plan. And that's why we were really adamant that the legislature needs to look at this as an ongoing funding need, as opposed to just every 2-year, think it over again. So we also had a little bit of work on community forests, probably not something that you all deal with. These are more semi-urban areas that have small forest areas, sometimes green belts, sometimes larger. In order to manage them, they're at risk of fire too. Just ask the people who live in Bonnie Lake last year. So a number of issues were dealt with in that regard as well. So, I mean, with that, that's kind of a quick overview. I will say one of the amendments to the bill, my bill that was added in the Senate, which I think is a good idea, is to direct the Department of Natural Resources as they begin this forest health effort, getting in and identifying and sort of evaluating forests that may need specific clearing or controlled burn, working hard at finding opportunities to market the trees rather than just cut them down and haul them away. Can we market them and set up private-public partnerships with mills and other entities to come in and take advantage of the land? After all, the Department of Natural Resources manages that land for the benefit of our school system. So we should be trying to realize is the best return we can, and that means looking at ways to try and market the product. So with that, maybe best if I take some questions, if there are any.
Are there any questions? We have nothing in the question and answer area at this time.
I will say, by the way, that this was a really strong bipartisan effort. My co-sponsor on it was Representative Joel Kretz, who lives in the heart of fire country in north central Washington, just out of up near Okanagan, and actually the thriving metropolis of downtown Wakanda. So he was great help. The member of the Natural Resources Committee, Representative Ed Orcutt, who is a forester. I don't know if Ed's on this webinar or not, but he was also very helpful and very supportive. So really appreciate the broad support we got. I think there was the recognition finally for those of us who live on the west side that fire is real. Last September, all we had to do was look at Bonnie Lake, look at the Olympic Peninsula in the last few years, and then look at the air pollution that we all endured here on this side of the mountains because of those fires. We had the worst air quality on the planet for about a week and a half last year. So it got everybody's attention, and tough way to get it, but we got it, and people really supported the effort. So.
Representative, that 1168 is very, very, very important to us, and we thank you for pushing it through as well as you did. And I know there was a lot of help from a lot of your constituents, but also in the forest forest products industry, there was quite
Absolutely.
help. And, but it's huge. This is huge. Thank you.
Good. Well, I hope we can look back 10, 20 years from now and realize that on the one hand, we're not going to prevent wildfires necessarily, but what this will hopefully do is reduce the intensity and the frequency. So hopefully, hopefully that will be a good story to tell 10 years from now. So thanks for having me.
Thank you, Representative. And yes, Ed is a member of the commission, and I think he's online here. And
Good.
tell Joe Kretz to come back to the west side so that I can talk to him again. It's been about 35 years, so he got.
I am fond of reminding him that he grew up on Mercer Island.
Yeah, right. Right. Okay. Yeah.
All right. Thanks, folks.
Thank you. Thank
You
you. And we're going to skip the break again and delve into the hardwood export lumber market. And Dr. Kent Wheiler is from the University of Washington, and Kent is going to speak on some of the things he's come across in 30 years of experience managing private international forestry business operations, and some of his academic studies here since July of 2017 when he joined the UW as an associate professor and the director of Centrifor, which many of us know well about. And he's been doing research on forestry and forest products trade, sustainable raw materials, and global supply chains. There's that three-letter word again. You know, the China trade war was a significant blowback to the hardwood industry. During the former administration, there were some issues with tariffs, as we all recall, and hardwood was hit pretty hard, particularly the ones on the East Coast. Not so much on the West Coast when the Chinese realized that they couldn't get alder anywhere else. So, but he'll talk about that. And Kent, welcome, and I'll turn it over to you.
Mute, Kent.
I was just going to say that.
Okay.
There it is. Sorry, we okay?
There you are. Yes.
All right, so let me back up here. I'm a little bit. Okay, there we go. So I'm appreciate the opportunity to speak with you again. I know we're short on time. I will go through these slides fairly quickly. And if you want copies, just email me. My email's on the last slide, and I'll be happy to send them to you. So last time we met was June 2019, when we were just beginning to see the impact of the trade war that Joe just mentioned. At that time, hardwood lumber exports to China had dropped 17%. And by March of 2019, they were down 40%. So they were down 17% in 2018, and then another 40% in the first quarter of 2019. And things got worse from there. So let's back up a moment and cover some historical context, because what happened with the trade war has had an impact on the shortages and the high prices we're seeing now. This is a graph from HMR Executive that shows a 60-year history of hardwood lumber production in the United States. It doesn't include Western hardwoods, but Eastern hardwoods are the bulk of US production. Output peaked in 1999, but started to decline as furniture production shifted to China. You can see that start of the decline right there. And then it just fell off a cliff with the housing crisis. I mean, it was a huge crisis. It really was. The post-recovery here from 2009 was basically the industry moving to China to follow furniture production. And then we had the trade war here and COVID, which was another catastrophe. So what we see here, the orange line is US hardwood lumber exports to China. This here was the phenomenal growth between 2009 and 2017, when following AHEC's lead, we moved into China and started supplying industry there more heavily. China's imports surpassing in 2016 the total volume shipped to the rest of the world. So we were sending more to China than to the whole rest of the world combined. And while US hardwood industry would have preferred that furniture manufacturing hadn't moved offshore, it did. And so the industry's ability to successfully transition to China was, I believe, an incredible success story. Here's another way to look at how this has changed over the past 20 years. In 1999, 84% of hardwood appearance grade lumber produced was consumed domestically in the United States. But as furniture manufacturing shifted overseas, the industry had to follow. And we by 2018, we're at a point where a quarter of all of our appearance grade lumber was going to China. So 1 out of every 4 boards, appearance grade boards that we produced. Then in 2018, 2019, we had the trade war and COVID, and that destroyed about, in those 2-3 years, destroyed about half of those gains from 2009. Initially, hardwood exports were not impacted directly by the trade war, although buyers began to slow purchases due to uncertainty about what might happen. They didn't want product to be on the water on its way over, and then some big duties get slapped on it just before it arrives. So in September, though, China implemented tariffs of 5 to 10% on wood products, among other things, in retaliation for tariffs imposed in the US on Chinese merchandise. And then in June of the following year, in 2019, the trade war escalated and tariffs ramped up to 25% on some products. And we see the frankly foreseeable and huge impact with log and lumber exports dropping by $1.5 billion. So the industry lost $1.5 billion of sales to China. And all of that inventory now, with nowhere to go, had an impact on prices, of course. And so around the world, not even with the China and the trade war, we lost $2 billion worth of sales. Because China was such a big customer and there were not feasible alternatives, alternative markets, inventories climbed and prices dropped. China was just too big. In 2017, it was 54% of volume and 57% of value. Vietnam picked up a little bit of that as furniture makers shift across the border, but Vietnam's really a very different type of buyer. It's like China was in the early days, with the emphasis on lowest prices and the cheapest grades. Notice in the chart, in the pie chart on the left, which is volume in billion board feet, that Vietnam, Canada, and Mexico have a larger share than they do in the pie chart on the right, which is the value paid in US dollars. And it's the opposite for China and Europe, and that's because China and Europe are buying higher value grades. So to put this in perspective, the sales lost in China are nearly equal to a complete loss of all US log and lumber sales to Mexico, Japan, Vietnam, and Western Europe combined. So it was just really devastating. That loss of market share was unfortunate because most of the lumber going to China was staying there. In 2000, 85% of what we shipped to China came back in furniture and cabinets and flooring. But by 2016, Chinese purchasing power had grown enough and housing was booming there, and 80% of what we shipped to China stayed in China. Two groups heavily damaged by the trade war were American soybean farmers and wood product producers. And as you remember, there was $28 billion in trade war relief given to American farmers who certainly needed it. Nobody begrudges that. But none of that money was shared with the hardwood industry. So in summary, what happened was really regrettable. The US was 10 years into the longest economic expansion in history. 2018 and 19 should have been more growth. What had been achieved in China was an impressive marketing success story, but instead the hardwood industry became a casualty in a trade war that wasn't even about wood trade. And then when the end was in sight, COVID struck. And after the trade war, the hardwood industry was reeling, and COVID was a vicious blow. It dropped production 26% last year to the worst year ever that over the time since the 1960s, when they've been keeping track of hardwood production. So in summary, the past 2 to 3 years have been extremely challenging for the hardwood industry, eroding supply capability. If there's a bright side, is that the trees kept growing. We have the resource, but we need demand to return, and that's going to rely on exports for appearance grade hardwoods. That's going to rely on exports. We just no longer have the manufacturing capacity in the US. With robotics and automation. Maybe some will return, but it will be slow and relatively small. A robust export trade in appearance grades will keep the industry healthy. So we really need to hope it bounces back. Unfortunately, so far we're not seeing it. To some extent, it's a lack of demand, but largely it is because the supply chain got messed up and we're having trouble getting the supply chain back in order. This is total monthly exports to all countries over the past 3 years. Exports have ticked up slightly from this time a year ago, but remain down considerably from 2017 levels. On the bright side, volume in 2021 was the best since October 2019, and with 12% higher prices. The poor recovery of global exports is largely because exports to China remain flat and half of what they were in 2017. Exports to Vietnam grew a little, but the growth in Vietnam is really disappointing, and the reason why is here. US furniture imports from Vietnam have doubled. They've gone up to $7.5 billion. And yet look at, you see almost no growth, 19% growth compared to 89% growth in what Vietnam's buying from us. So I hope the industry can put more pressure on buyers in Vietnam. Alder exports dropped a lot, 70 million down to 20 million. It did have a pretty big impact on Alder in Washington. And we're seeing no signs yet of recovery there. So there are several reasons for this. Demand is good, but the supply chain got messed up and is struggling to catch up after shutting down after the onset of COVID. Mills have struggled to get people back to work. The labor shortage has affected log supply and finished good inventories and deliveries. There are truck and container shortages. Sawmills are even there's even a lot of hardwood mills now that are cutting softwoods because the price for softwoods is so high. So it's just, there's a lot of problems with the supply chain that we have to work through. And then of course, in addition, we've lost some capacity. As you all know, the Mount Vernon mill shut down, and there are other mills that have shut down. So we've lost some capacity. For sure, we know that production and manufacturing will respond to demand. There will be a recovery. The current supply chain problems will get resolved to some extent. We'll see some improvement over the coming months. I'm sure we will. But there's been real structural damage that isn't going away and is going to hamper that recovery for a while. And with that cheery note, I'll end with that and hope this information's been helpful. There's my address, kweiler@uw.edu, if you have any further questions or would like any more information. information. Thank you.
Kent, this is Dave. Thank you very much. And we have a question, and I think you're smart enough to answer this.
That's a
I mean,
big
'cause
leap of faith, Dave.
you are brilliant, so you should be able to answer this. Change of topic, if that is okay, is the question. And what is the future of carbon capture cash to landowners?
Oh, man. I'm sorry. I cannot answer that question.
Okay.
My colleague, Indranil Ganguly, does a lot of work in carbon, and Francesca Pierbone, both my colleagues. I let them do that. They're the experts, and I'm sorry, but I cannot answer that question.
Okay, we'll get that answered to you, Howard. Thank you. And see, there, is that the, yeah, that's the same. That's the only question.
Okay, sorry.
Thank you, Kent.
Mhm.
Back to you, Joe.
All right, thanks, Kent. And yeah, go dogs. Our last speaker, but not necessarily least and last, because he's maybe talking about an interesting project that he's been working on. Neil McLeod and his son have been doing some work on maple syrup in the Northwest. I think a lot of us are used to Vermont maple syrup, and this is kind of a new idea. And there's been a few articles. I know I looked at them because I remember reading them back in 2019, and another one here recently in May about Neil and his son's operations, including their organic farm up north. And Neil's from Northwest Washington. He started out as a fisherman, and I guess, Neil, you must have got tired of the water and decided that you wanted to start working on solid land again. So he's going to talk about how the maple syrup program started and how he's trying to commercialize that. So Neil, I will turn it over to you. And I wish we all had a sample, because I'm sure your stuff's pretty tasty.
Unmute, Neil.
Unmute. Can you hear me now?
Yes,
Okay.
thank you. Welcome.
Okay, we don't have much time, so I'll get right to it. My name's Neil. I've been tapping big leaf maple for roughly 10 years. 4 years ago, I went commercial with it. My son showed some to a restaurant in Seattle. They tried it. They wanted to buy everything I could make. We get a good price for it. So I drove to Wisconsin that year, 4 years ago, bought an evaporator. Came back and realized that now I had the capacity to cook sap. I didn't have the capacity to pull the sap out of the trees. So we bought the equipment, and that takes us to now. Devin, want to hit the picture of my... Okay, that's a picture right there of a 1-inch main line, which I run through the woods, and it runs to my extractor vacuum system. Each, the 1 inch is tied into the 5/16 tubing that runs to the tree with a tap. And when the sap's running, you turn on your vacuum, it pulls it out of the tree into the extractor, which is the big blue barrel. On your left is my vacuum system. Had a lot of problems to begin with. On the sap on the West Coast doesn't work like the sap on the East Coast. I get a lot more foam, so we were burning up a vacuum probably at least one a year. I'm running 4 different vacuums on 4 different sites. So it comes into my extractor. From the extractor, it fills up, pumps from the extractor to a holding tank, which is I'm using a stainless steel refrigerated milk tank. As I fill that up, I run it through reverse osmosis. I got really low sugar content on West Coast. We're running at 1% sugar. The East Coast is normally 2% plus. Last year they were at 1.6%, which isn't not a big difference. Clean across the nation last year, it was warmer than average. So we made about 2/3 of the amount of syrup that we should have made, both on the West Coast and the East Coast. That's a picture of my reverse osmosis. So I'm taking my 1% sugar, the sap, running it through the reverse osmosis and building it up to about 7% sugar content before I run it into my evaporator to start cooking it down. That's my evaporator. It comes into the main tank, which is the long, which is to your right. You start cooking it off there, and it works its way slowly forward into the two finishing pans at the front. Once it gets from 6% sugar up to 66.5%, which is what you're looking for. You don't want to get it too low or it'll mold. If you get it too high, it'll crystallize. It automatically pours off through your into a pan, where then I run it as, it'll be real cloudy looking like chocolate milk. You run it through a filter system where it filters out all the minerals that are in the syrup. And that's my filter system, the bottle of finished syrup. I'm running it through a filter system into a bottling system where you pour it into the bottles and label it and sell it. We have no problem whatsoever selling. Our big problem is finding good stands of maples. We've chopped our maple trees down for firewood. When I was in high school, we cut firewood, $25 a cord, and maple was what you were looking for, good hardwood. So it's really hard to find good stands of maple trees. I should be running off of one pump will handle 3,000-4,000 taps. I'm lucky to get 700 taps. I'm running, you know, maybe a mile of the main line through the forest. So this is a big problem for me. We've started planting maple trees. You know, it's going to be a 100-year project, what we're working on, but I think the future of mapling in the Northwest is going to be, you know, planting mixed forests of maple trees. And you're going to be planting, I'm not talking about planting up on the hillsides where it's Douglas fir. I've tapped a lot of trees on the hillsides and you get very little sap out of them. Where you want to be is down in the riparian areas, along rivers, creeks, just anywhere where there's a high water table, inland. If you get close to the salt water, you don't get the cold to kick off the sap runs. So I'm working up in the along the foothills, in the valleys, where there's a high water table or along a creek. That's where I'm getting sap. Let's see, we still got a few more minutes, I think, or are we out of time?
Maybe talk a little bit.
Okay, and
No, keep going. We do have a question. Maybe it's a good time to break in for a question.
okay, Glenn, we've got a few minutes. Okay, yeah, go ahead and ask any question you want.
How often do you move your taps during the winter? And how close to an old tap location can you put a new tap?
Okay, when I retap, and that always depends on weather. If you have an average winter, I probably only have to retap twice. The tap, if I have a warmer than average winter like last year, I retapped 3 times. That warm weather, when it hits 50 degrees, you get so much bacteria in your lines, it plugs up the hole. You cut off your old tap, put on a new one, retap, and I retap. Usually I go over 4 inches, up 4 inches. I can tap from, say, a foot off the ground up to, sometimes we're up 10, 12 feet off the ground. I try not to go that high, but if also I'm trying to get enough drop. So it's always running downhill, so it assists the vacuum system I have. Of our vacuum systems, we're using AirTech vacuums. We're probably pulling about 28 inches of mercury, which pulls a lot of sap. When sap's running, I've seen it run where we've been getting 80 gallons an hour of sap coming out of with out of 700 taps.
Okay, have two more questions.
You bet.
My big leaf maples, about 2 dozen, are about 3 to 4. He says inches in diameter. I wonder if he means 3 to 4 feet. How large should they be before I start tapping them?
Usually the 12 inches on up. We've played a lot in the last couple of years with smaller trees, like 8 inches. I think that I can tap those trees, pull sap out of an 8-inch tree without killing it. But generally speaking, you wanted a 12-inch or bigger tree. I like really big trees. I've read where some people don't think they put out as much. I've got trees that are 3 foot plus across, where on a gravity drip, I'm getting 10 gallons of sap overnight. If you hook a vacuum up to that same tree, you should about double the outflow. So I'm a big fan of big trees.
Okay, so maybe, I guess he really did mean 3 to 4 inches because it's coming on, it's getting bigger.
Okay, well, I've tapped trees that are 3 to 4 inches, but you wouldn't be drilling them. That's for, yeah, I've been cutting the branches, and I think you get 1 drop every 4 seconds off of a little branch off of say a 3-inch tree. A lot of work. I was thinking about hooking up a vacuum and seeing just how much I could pull out of if I had enough small trees. That would have been an interesting project.
Yeah, he came back and said he is talking about inches, and so I heard you say probably when they get to be maybe 7, 8 inches is when you might start.
Yep, that would be the earliest, and not a lot. Well, there's no research done on tapping trees really on the West Coast. I think University of Washington's working on it. I am the only commercial producer in the state of Washington. More interest is being shown. A lot of people have got a hold of us, but nobody commercial. Maybe next year there'll be another commercial site working up in Whatcom County, is what I'm told.
Okay, this is tied to it. We're talking about diameter then.
Yep.
Now the next question is age range. What is the best age range to tap a maple?
Yeah, I have trees that are 80 years old that I'm tapping that do really well. And I also have trees that are probably less than 20 years old that do really well. I think probably an average, I would be looking for trees that are 40 to 60 years old, somewhere in there. But all trees produce sap. It's where they're placed. Okay, they have to have feet wet. If you're on really dry ground, generally speaking, you don't collect sap. Last year, I think we had 30 some thousand gallons of sap we pulled. I think we can do a lot better than that, though.
Okay, that's all the questions that I have here right now.
Okay. Thank you for having me on.
Thank you, Neil.
Okay.
Thanks again, Neil. Appreciate you.
Oh, and I would like to say thanks to Al Craney for all the help he's given us, just in case he's out there listening. He's been great to work with. Thanks, Al.
Okay. So those of you that want to hang around or want to answer or ask some questions, I guess if we can't answer your questions because the panelists have to leave, Dave, I think we can leave it open if people want to put something in the chat or the Q&A. And I believe we can copy those questions.
We can copy those questions and we'll get answers
Yeah.
to them.
Yeah.
Before people leave,
Sure.
just before people leave.
Go ahead, Dave.
We have something. Okay.
Just talk.
No, I got to get rid of this.
They can't see that.
Oh, I'll get it. I can't read. Oh, here. Okay. Joe is retiring from the commission. And this, we want to recognize him for his long-term service to the commission. He's been the chairman from 2018 to 2021.
Okay, that wasn't that good.
He started as a commissioner in 2012. This certificate that you see on the screen, we will get that framed and sent to Joe, but we appreciate all the hard work that Joe has done. Thank you very much, Joe.
You're welcome. Thanks, Dave. And hopefully that can be framed in a maple frame. And
I
that'd
think
be
it's going to be an alder frame.
yeah, that'd be fine too. I prefer
It
maple.
won't be plastic, that's for sure.
No, well, thanks.
Thank you,
Oh,
everyone.
thank you. Thank you very much. And I had a great time participating in this industry for many years. And it's about time some of the younger guys started stepping up, and it sounds like they have. I see a few of the names on there. So, and for those of you who joined our webinar, I hope you enjoyed it. You know, we have a symposium every year, and we also have a website where you can go to get some more information. I think there's some questions about the Alder handbook and topics like that, but I believe the website, I should know what it is, isn't it? Is it hardwoods.com, Dave? Is that right?
Yes.
Yeah, it's not Washington Hardwoods.
No, it's Hardwoods.com,
Yeah.
C-O-M-M.
That's right. That's right.
.com.
Hardwoods.com. But I think those handbooks and where you can get them are on there. There hasn't been a lot of updates to those over the years. I know that some of them are fairly old. They've been around for a while, but the commission continues to follow up with studies and research and outreach to to modernize some of those studies. And unfortunately, no one's. I think the last compendium we had, the big one, was 2005. Was that right, Dave?
Yes.
Yeah. So maybe it's time for another one of those. I don't know, but anyway, I'll turn it over to you, Dave, and I'm going to sign off here. My
Okay.
picture anyway. I'll leave my audio open, but I think people have seen enough of my face. So thanks.
And for those questions that we didn't get answered, yes, we will be answering them. And we're hoping that all this will be available on our website. Thank you all for joining, and you have a good rest of the day. Thank you.